We just added movement to our card using our finger. That's pretty cool. The next thing we want to do is we want to add some animations. One animation that we will need is when the user lets go of the card but isn't outside of the thresholds. What should happen is the card should shoot back to the center and allow them to reswipe it if they need to. The other animation we want is if the user is in those threshold regions, then the card should swipe off according to whether they're on the left side or the right side. Let's add the animation to center the card back when the user lets go within the threshold. When the user starts panning the card around and they lift their finger up and they are not on the threshold for selecting true or false, the card should snap back to the center. We can create a function in our card class that will perform this animation and snap the card back to the center. One issue that we have right now is that we actually are changing our center as the user is moving the card around. We can resolve this by creating another variable that just holds on to that original center location. That way, when the user lets go, we can set our card view's center to this original center variable. So let's add that. So if we go back in our code and we go to our card view class, just underneath the statement label, we can create a variable original center. And this is going to be a CG point. And right now, I can just set this to be 0. Because we're going to set our center as we create our card, we don't need to set it right here in our local variable. Going back to our view controller here, where we're actually setting the center of our card view as we're creating it. This is in our viewDidLoad function. If I just go down here and type card view dot original center, it's equal to center. Let's create the function for returning the card back to the center in our card view class. If we go back to statement card view and scroll down, at the bottom here I can say func, and I want a name that is easy to discern what it's doing. So return to center. And this will be where we add all the code to return the view back to the center. At this point, the question then comes, how do we actually perform the animation? Luckily, Apple is ever so generous, and they have given us the tools that we need to perform these animations in our UI kit. Before we dive right into the code about animation, let me discuss what animations are. Animation, in a very general sense, is simply movement. There are two key factors involved with animation: transforms and time. Transforms is simply the change in its position, rotation, or scale of a certain view over the time, which could be in seconds or minutes or whatever. Let's see how this is done in code. To use the animate function, we can go UIView dot animate. And you'll notice that there are quite a few different functions with different options for you for animation. For right now, let's go ahead and select the first one, as it's the one with the least amount of options. Again, there are two requirements in the most basic animate function: time and the animation, or whatever type of transformation that you are looking to do. Now, movement isn't the only thing that can be animated within an object. There are different properties that's known as being animatable. Besides just movement, you can also animate things like the color of a particular object. Pretty much anything that has a general value that can be changed over time usually is animatable. So going back in, let's look at the animate and fill this out. So with duration, it's asking for a time interval. In this case, we can just give it an amount of seconds. Let's go ahead and do half a second. I think that's going to be good. Now you'll notice that the animations has this weird requirement. It's got some parentheses and an arrow void. What's great about Swift is we can actually pass in blocks of code into parameters. In this case, it's requiring a block of code. So if I put curly braces here and hit enter, now for this animation, I can do whatever I want in here as a block of code that will run as my animation. The animation, again, that we want here is we want to set our card's center property to be the original center that we stored previously. So let's take a quick look at how this animation function is going to work. Since we set a duration of 0.5 seconds, what's going to happen is it's going to take our current center value, and over this block of time, it's going to slowly turn our center into our original center, or slowly move this value to our original center value. So if, for instance, the card is somewhere at the top, in half a second, it's going to calculate how to move this point down back to the center point, which gives it this movement or this look of animation. So our function is all set and ready to go. Now we just need to actually call our function back in our panning so that it returns to the center. So let's go back into View Controller and go back to where our pan card views is. So the only time that the return to center function should be called is when the user actually lifts their finger. Luckily, with our gesture recognizer, we can actually check for that within the function. So going back in here, I can go within this card view conditional, and I can say if sender dot state, and if you look at here, it'll say that it's the current state of the gesture recognizer. And this is great because I can do another conditional here. So I can say if our state is equal to, so you might not know what state it should be. What's great about Swift is a lot of these properties we can access, or Swift knows what property it's looking for. So if we type dot, you'll see that it gives us a bunch of UI gesture recognizer states that is available, which is great. So we can go here and see began, canceled, changed, ended, failed, possible, recognized. And the one that we want here is ended, which is simply the panning has stopped, the state has ended, so we can perform this code. So this conditional already checks to see whether the user lifts their finger. So all we have to do here is say card view dot return to center, at least for now. Later on, we're going to need to check to see whether it is within the specific thresholds for swiping left or right. So we'll need to handle that later on. But for now, we can just return it to the center. Let's give this a shot and see if this works. Awesome. So if you notice, as I drag this, and I'm still holding my finger or my cursor down, when I let go, you'll see the card just goes right back to where it originally was. And it doesn't just snap back instantly. It's doing this over a period of time, or half a second. Great. This is adding some really cool animations into our app, and it's taking care of a lot of cases. One, sometimes a user just naturally by accident will lift their finger up, and we shouldn't penalize the user for doing that in certain cases. This animation allows the state to go back and allow the interaction to happen as intended for each card. This is only one animation that we've utilized so far. We still need the animation to swipe the cards off. In the next section, I'll show you another really cool animation tool that we can utilize to swipe the cards left and right. We have our cards recentering back to our view if the user lifts their finger after dragging around. However, it doesn't swipe off yet. So even if we do go off the sides, it still doesn't swipe the cards off, it just goes back to the center. When the user tries to swipe the card off, it means that the user is intending to answer the statement of whether it's true or false. So we can create a specific function to answer the statement, and the first thing we want to add is the animation to swipe it off. Let's define those areas of where the card should actually be swiped off or whether they're returned to the center. So let's say that the left 20% of the region is going to be dedicated to being the false answer, and the right 20% is going to be the true answer. Now we could use the UI view animate function that we used previously to return it to the center, but I want to show you another great tool that Apple provides for us, which is the UI dynamic animator. iOS has a really cool physics engine that allows you to conform your views to match the rules of physics. We can do things like collision, add gravity to our views, and a lot of other things that we would normally use physics for. In this case, I want to take advantage of one specific thing known as a push behavior. A push is simply just taking your view and pushing it off some direction off the screen. Let's take a look and see how this is done. Let's go back to our statement card view object. And here I want to create a UI dynamic animator object. So in here I could say var animator is a UI dynamic animator. And a reminder, we're putting an exclamation point here as, again, the coding buzzword, implicitly unwrapped optional for our animator. This is because within our constructor down here, I'm going to actually create the object. So there's no leeway for this object not being there. So back in our constructor, I'm going to go down here and say self.animator, since it's our local variable, is a UI dynamic animator. And if I type the open parentheses, I can look at the different ways to construct this object. Looking at the third one, it shows that it's asking for a reference view, which in our case we want that because we want to have our card view be the reference view. So I can hit enter, and our reference view is simply self, or the card view. Now that we have our dynamic animator object, we can create a swipe function within our card view. Let's go ahead and start with just a standard function creation. So if I go down here again, do func swipe. And in this case, I want to take a parameter. Because you can either swipe the card left or right, I want to take the answer as a parameter to know which direction I need to go. So here, I'm going to take an answer, which is simply a Boolean. Within our swipe function, we can go ahead and create the right behavior of what we want to happen. In this case, as I mentioned, we want to utilize a class known as UI push behavior. Let push behavior equals UI push behavior. Again, if there's any specific class that Apple provides that you are confused on or want to read more about it, if you hold the option and click over the class name, you will be able to see more information. So I can go in here, and if I do class reference down here, I can read a little bit more about this. In this case, it says a push behavior applies a continuous or instantaneous force to one or more dynamic items, causing those items to change position. This is exactly what we want here. So if I try to construct this again, you'll see that there's two requirements: the items or the UI push behavior mode. A UI dynamic item, you may not know what object that is, but I will tell you right now that the UI view does adhere to this protocol, which is great because now we can say that the items that we want to adhere to this push behavior is the card view. So we're basically saying, hey, I want my card view to adhere to the push. So, and remember, if you look here, it's asking for a UI dynamic item array. So it can take multiple objects. In this case, I can just say with an open bracket, self end bracket, which is just one item. So it's just the one card. Now, if you look at the mode, it says it's requiring a UI push behavior mode. Sounds like something that I can probably figure out if I go into this and type dot. Swift will give me the options that I can use here. The two ones I want is continuous and instantaneous. Just looking at the words instantaneous, I see it says instant, and I want the push to be instant, so I'll select instantaneous. Now, you may or may not have taken physics before, and if you haven't, that's totally okay. You can look at the documentation and see what this push behavior requires, and I'll tell you in this case what we'll need is we'll need a direction and a magnitude. However, we're only moving left or right, so we really don't need to worry too much about the direction because that's already sort of defined in the magnitude. If you go negative or positively, it's going to go left or right accordingly. And again, the answer parameter that's being set in our swipe function is really the determining factor for whether the magnitude should be positive or negative or move left or right. We can use a conditional here to do that check, similar to what we've done before. However, I want to show you something new. And this is one of those other nifty coding buzzwords again. And this one is called a ternary conditional operator. Now, before I write this in our code editor, I want to show you what the magnitude is going to look like using the ternary conditional operator. Now, this looks super confusing, and even the name sounds confusing, like ternary conditional operator. What's going on? Trust me, it's much easier than you think. You could think of this as a condensed version of an if statement. Now, just so you can see what an if statement looks like again, let's put that on the screen as well. Ali, can we do that? So we have our if statement here. Now let's compare these two and see how they're similar. If our answer is true, then our magnitude should be a positive number and therefore go right. Otherwise, it should be left, and our magnitude should be negative. However, if you look at this if conditional, it's taking up more lines of code, and it's just a little bit more to read. Now let's go back and look at this ternary conditional operator. And this looks really confusing, but let's read it from left to right and kind of get an idea. So we're going to set our magnitude value. And the condition we want to look at is our answer. So if our answer is true, or you can think of it as answer question mark as is this true, then it should set our magnitude to this value. Otherwise, or colon, it should be this value. So you can see how an if conditional can be broken down into a single line that is, once you understand it, much simpler to read and easier to write out. So again, if our answer is true, then it should be this value. Otherwise, it's this value. Pretty simple, right? So let me go ahead and add that. So let magnitude, and I want this to be a CG float type, is equal to now answer, and if it's true, it's 20, otherwise it's negative 20. Now our push behavior is expecting this magnitude. So if I go back to push behavior and I look for the magnitude property, you'll notice that it's right here, the magnitude of the force vector for the push behavior. So I can just set that to the magnitude. So our push behavior is basically set up, but we still need to add this to our dynamic animator. So I can type self.animator.addBehavior. So you can see right here, there's already a function that's add behavior, and I can add this push behavior to this animator. We created our function, but now we actually need to call that within our view controller. So let's go back to our view controller. Now, as I mentioned previously, the place we're actually going to need to call this swipe function is within our pan card views function. And if you go back, it was in this conditional when the user lifts their finger up where it should either return to the center or it should go to left or right side. Now, before I start adding code into this section, I feel like this view controller, we should create another function here. When they swipe the card, not only does the card get swiped off, but it should also update our score. So we should probably separate this in its own function. Let's do that. So down above the pan card views, I can make a func answer card. And similarly, I can take the answer here. So going back to our panning function, we can go ahead and start adding the code to determine whether to swipe off. Now let's think about this in terms of the width of our screen. If the user lets go in a region that's less than 20% of our width, then it should swipe off to the left. Or if it's greater than 80% of the width, then it should swipe off to the right. Now, how do we get the percentage? Well, for one, we can do this math function, which I'll show on the screen right here. Now, if you look at this function, it's pretty simple. We're just taking the center of our current card view, and we're dividing it by the entire width of our screen. This will give us a value between 0 and 1, which is more so a percentage of where the view is along the x coordinate of our screen. To integrate this math equation into our code, let's go back down into the pan card views where the state is ended. So in here, I can create my normalized x value, and that's equal to the card view.center.x divided by the self.view.bounds.maxx. So again, we're taking a function that we kind of thought about on paper and integrating it into our code. And remember, we have these checks, right? So we can use a conditional to check to see if the value is under 20%, greater than 80, and if it's neither of those, it's in the middle, and we could return it to the center. So I can do it like this. If normalized x is greater than 0.8, then we want to self.answer card true. Again, because if they swipe it off to the right, we are saying that the answer that they're giving is true. Else if normalized x is less than 0.2, self.answer card false. If it's less than 20%, then we're assuming the user is saying that this is false. Lastly, else, we can take this code right here and paste it here. And I'll just make sure that's tabbed. So let's look at this one more time. If our normalized x position of when the user lets their finger go is greater than 0.8, we answer the card true. Else if the normalized x is less than 0.2, we answer the card false. Otherwise, we return it back to the center. We could just have the swipe function in our card view, but before we do that, I need to actually get the card view. If you look back in the pan card views, you'll notice that we're getting the card by calling .last, which we could use the same exact construct to get the card view. However, when they answer the card, like I said, we want to actually remove that card. There's another way we can remove the card and still pull the card that we need at the same time. Rather than using last, we are going to use pop last. What the pop last does is it's going to take the last item in the array, and rather than just give us the variable back, it's going to remove it from the list or the array, and it's going to give it to us back as a variable. Let's see how this is done. in our answer code, we can say if let card view equals self dot card views dot pop last. So you can see that this is very similar to what we did in our pan cards, but there's a slight difference with the pop last. And again, this is because since they're actually answering the card, we can finally remove it from our array. Lastly, we just need to type cardView.swipe, enter. And again, since we already have the answer up here, we can just pass that through to our card view. I think that's actually everything. There was a lot of stuff there, but let's see if we did everything correct. Okay, so now we have our app back up, and you remember we had this region that if we were to just let go, it will return it back to the center. Now, if I try to move it off to the left and I let go, whoa, you'll see that the card is actually being pushed off from one side. Okay, it looks like it got pushed off to the left. Let's see if the right works. Look at that. Look at that. Not only did we have some cool animations to return the card back to the center, but now we have a way to actually pop the cards off. So you're noticing that we're actually able to access the next card as we're pushing them off. Why is that? Well, remember how with pop last, we're saying that we're removing this item from the array. Well, what's cool about that is now when we start panning again, and we go back in our pan function and we're calling this cardViews.last, the last item in the array is now the next thing up, which is the next card. So by nature, we're not only removing the other card, we're now letting the pan gesture work for the next card underneath. So this was another jam-packed module, and I'm glad that you made it to the end of this one. And the reward couldn't have been better. We now have our cards animating, returning to the center, and even swiping off based on the user's inputs. There's still a few more things we can do to complete out the app. Our app still isn't really a game yet because the user has no idea whether they answered it correctly, and to be honest, we don't even know if the answer is correct or not because we haven't stored them yet. Our app also doesn't really have that flair or personality, so we can add some of that using our custom artwork in our cards. And finally, if we were to just go through the entire app and swipe off all the cards, it just sits there. The user can't do anything anymore. They have to manually try to close the app out. That's not the experience we want to give our users. We want to give them the ability to play the game again if they wish. The next module is going to go through all of that. So be prepared for another super jam-packed section where we're going to go through add scores, add custom artwork, and allow the user to play the game again. If at any point you were confused, feel free to freshen up with the resources we provided. And if you have any questions at all, just leave them in the comments down below. Let us know if there's anything you felt confused on, and I'll be more than happy to answer those questions. I'll see you in the next module.